Binary? Really? Binary? We have to learn this? Isn't it enough that we already know the decimal notation system? I gotta learn binary? Why? So I can figure out what the 1980s song by Rush meant when he was saying 1001. Anyways, there is great reasons that we should understand binary notation. Let's check it out in this IT first step. Decimal notation makes so much sense to us, I suppose, because we have 10 fingers, if you include the thumbs, and that's how decimal works. Remember, decimal is 0 through 9, and we also have a decimal point in the notation system. So examples, well, my current age, 49. My gray hairs, there's actually 114.5. Interestingly, one of my hairs is half gray, half brown. Don't know what's going on there. But this notation system works so well for us. And in fact, even when we need to feed numbers to computers, we love to represent those numbers in decimal because we understand it. Let's take a look at that in action. If you look at an IP address that's assigned to your computer, you would note that we are using dotted decimal notation to make it easy for us to read and understand. So we see 192.168.1.205. And thank goodness we represent it that way, because if we represented it as the computer needs to see it in binary, it would be this massively long string, 32 bits, in fact, 32 digits, zeros and ones in a row, and it would be very troublesome for us to try and remember that, especially if we need to memorize an IP address for part of our networking functions. But even though we love the dotted decimal notation, it is very important for us to understand the binary notation system, and there are times when we would want to work with it so that we know exactly what the computer is doing. With binary, as I alluded to, it's all about the zeros and ones. So if we see it in action, if we were to take one of the octets of the dotted decimal IP address that we looked at, and we were to see it in binary, we would see a string of zeros and ones. Specifically, this example, 11001101, has a nice ring to it. Now, you may wonder, well, what is that in decimal? How do you convert? And I have kind of a long answer for you. The reason why it's a long answer is I want to teach you in this video a skill that you can use for this exercise, but I think the most important part is you'll be able to use it well beyond this exercise. There are many instances in your work with IT where this can be valuable to you. So the first thing that I do is I build this row right here, this top row, and it is 2 raised to the 0, and then to the first, to the second, to the third, you get the idea. And I just need to remember that anything raised to the 0 power has a value of 1. And then 2 raised to the 1 power is that value 2, and then 2 raised to the 2 is 4. Notice it just doubles here as you move from right to left. So this table is very simple to construct. We just really have to remember this first value here, and then we can construct both rows of the table. So if we take our number in binary that we saw earlier, 11001101, and we plug them in the appropriate areas there, we can figure out what this binary number is in decimal. So this position is on, so we have 128, and then 64, and then 8, and then 4, and then 1, and whew, this is tough math here, 12, 20, 24, 25, carry the 2, 0, carry the 1, it's 205. Now, you could pull up a scientific or a programmatic calendar, like in Windows. You could pull up the calendar and say, I want to use the program view, and you could double check this. You could enter this number in binary and see if you get 205 in decimal, and I would hope that you would see that that's exactly what you get. All right, now we have to practice with something like this in order to truly learn it. And you'll be glad to know that I set up some practice for you. This would be a great time to pause the video and work this out on your own. What is 1101 in decimal notation? Pause now if you want to work this out, because I'm about to walk you through the solution. Well, here we go. What is 1101 in decimal notation? I think I can handle this. It would be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. That's 1, 2, 4, 8. We have 1, 1, 0, 1. The answer is 8 plus 4 plus 1 is the lucky number 13. Great job if you solved this correctly. Are you ready for another practice? I bet you are. Let's jump into practice 2. Here we're going to throw a little curveball at you. What is 65 in binary? Aha, this time you have to kind of work backwards. What's 65 in binary? Pause the video here. I'll be right back with the solution. Well, we are ready to solve this. We're going to go backwards a little bit, but it shouldn't be too hard at all. Are you ready? So I'm going to build my table. We had, let me do it up here, 2 to the 7, 2 to the 6. Hey, I'm going the other way this time. Woohoo! All right, so here is our table. And we know it's 1, 2, 4, 8, 16, 32, 64, 128. We have 65. Can we subtract 128 from 65? No, we'd get a negative. So there's a 0 in this position. Can we subtract 64? Yes, we can. And that would leave just 1. We need to represent 1 here in binary. That's going to be easy, right? 0, 0, 0, 0, 0. We couldn't subtract any of those from the remainder and not have a negative. It's a 1 in this position. And by the way, when you represent this, you can trim that leading 0. So the answer is 1, 0, 0, 0, 0, 0, 1. That's got a nice ring to it as well. So there is our 65 in binary. I'm sure you want one more practice example. I don't blame you. Let's do it right now. The third and final practice in this video is ready for you. What is 234 in binary? Pause the video now if you'd like to work this out on your own. Well, here we go. 234 in binary. All right. 2 to the 7, 2 to the 6, 2 to the 5, 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. Right now you're saying, Anthony, why in the world do you go through all that trouble? Why not just list the second row? Well, trust me, I go through all that trouble because later on, when I'm working with the math of binary stuff, specifically IP addressing and subnetting, that column comes in really handy to me. All right, can we subtract 128 from 234? The answer is yes, so there's a 1 in that position, and then I need to do that subtraction. That's a 6, that's a 0, that's a 1, so our remainder is 106. Can we subtract 64 from that? The answer is yes. We got a 2 there. We need to do this. We got 42 left. Can we subtract 32 from 42? Yes, we can. We got a remainder of 10. Can we subtract 16 from 10? No, we can't. Can we subtract 8 from 10? Yes, we can. That's a remainder of 2. And then, therefore, we know that's the remaining digits. So 234 in binary is 1, 1, 1, 0, 1, 0, 1, 0. I don't know why I'm talking like a robot. Maybe because I'm doing binary. Congratulations, you have survived this IT first step in which we have examined in great detail the decimal system. No, we didn't. We know that already. But our interesting part was comparing that to binary and learning how to convert in both directions. As always, thank you so much for joining me in this IT first step.